Imagine waking up at like 2 in the morning and it's the middle of July, you kick off the sheets, but there's no relief at all.
Oh, that is the worst feeling.
Yeah.
Just brutal.
Right. The coastal Florida air outside, it feels like warm soup. And suddenly, the inside of your house feels exactly the same. You listen, and the vents are totally silent.
Yeah, that silence is terrifying.
It really is. Your air conditioning has just failed, and you are instantly thrust into this high-stakes survival test against extreme heat and, 80 or 90% humidity.
And it's a visceral, panicked feeling, honestly. I mean, we tend to think of our homes as these impenetrable fortresses, right?
Sure, yeah.
But from a mechanical standpoint, a house in that kind of coastal climate is just constantly under siege from the elements.
Well, welcome to the deep dive. Today, we are looking at a really fascinating stack of technical insights, service guides, and industry materials from Envairtech Heating and Cooling, Inc.
Yeah, they're an HVAC authority based out of Bradenton, Florida.
Right? Serving Sarasota, Manatee counties, all those surrounding coastal areas. And our mission today is to take something you probably never want to think about. I mean, air conditioning maintenance.
Nobody wants to think about it.
Exactly, but we're going to flip it completely on its head. We are going to transform this into an exploration of building science, thermodynamics, and the hidden economics of how you actually keep a house comfortable without, quietly draining your bank account every month.
Because the way most of us interact with our cooling systems is, well, it's fundamentally backwards, especially in extreme climates.
How so?
We treat our HVAC units like a television. We turn it on, we expect it to work, and we just don't think about it again until the screen goes black.
Okay, let's unpack this, because the documentation we're exploring today makes a really compelling case that in an environment with corrosive salt air blowing off the Gulf and, hurricane-level stress.
Yeah, the Florida environment is no joke.
Yeah. Right. It says that wait until it breaks mentality is just a financial time bomb. But I have to be honest here. I want to push back on this whole idea of proactive maintenance or scheduled tune-ups.
Okay, let's hear it.
As a homeowner, I look at my thermostat. It says 72 degrees. I feel the vents, cold air is coming out. Writing a check to a technician to come look at a machine that is already doing its job feels, frankly, like a scam.
I hear that all the time.
I mean, is a tune-up actually doing anything if the house is already cold?
That is probably the most common objection in the entire industry. And to answer it, we really have to look at what is happening inside the metal box. Because a true precision tune-up is not, it's not just a guy showing up to swap out a dusty gray air filter.
Right.
It is a comprehensive physical for the respiratory system of your house. Take the evaporator coils, for example.
Not like the coils.
Yeah, these are the metal fins inside your indoor unit that actually get cold. Over time, dust, pet hair, microscopic debris, all that slips past your filter and sticks to those cold, wet coils.
Well, I'm assuming that's bad, obviously. But if air is still blowing through the vents, why does a little dust actually matter?
Because that dust acts as a literal insulating blanket.
Oh, wow. Oh, wow.
Right. Air conditioning works on the principle of heat transfer. The system isn't, magically creating cold air out of nowhere. It is absorbing the heat from your indoor air and moving it outside.
Got it.
So if your coils are covered in a layer of grime, the warm air blowing across them can't physically touch the cold metal. The heat transfer is blocked.
So the house might still feel cold to me, but the machine is, struggling?
Exactly. Your compressor outside is running for 12 hours a day instead of 6, just to achieve that exact same temperature. You are burning massive amounts of electricity just to fight through a blanket of dust.
Okay, so the tune-up essentially pays for itself by stripping off that insulation and getting the machine back to its baseline efficiency.
You nailed it.
You are basically paying a small amount up front to stop the machine from quietly stealing from your wallet on your utility bill every single month.
Yes. And honestly, the efficiency loss is just the financial side of it. The physical damage of neglect is, well, it's much worse. Let's talk about the condensate drain line.
Okay.
This is where the thermodynamics really catch people off guard. Because an air conditioner is essentially a massive dehumidifier.
Right, it pulls the moisture out.
Yeah. As it cools the air, it wrings moisture out of it like a sponge. In a humid coastal climate, an average residential AC is putting gallons of water out of the air every single day.
Gallons, wow. And all that water drips into a pan and runs outside through like a little white PVC pipe, right?
Right. Now, combine gallons of standing water with dark, warm Florida attic temperatures.
Oh, gross.
Yeah, it is the perfect breeding ground for algae and mold. If you aren't having a professional clear and treat that line during a scheduled tune-up, they usually flush it out, that algae will grow until it forms a solid plug.
Which means the water has nowhere to go.
Exactly. The water backs up, the pan overflows, and suddenly you aren't just calling a repairman because you're hot. You're dealing with catastrophic indoor water damage.
Oh, man.
You've got ruined drywall, warped hardwood floors, and potentially toxic molds growing in your ceiling.
All because a 50-cent piece of plastic tubing wasn't flushed out.
Pretty much, yeah.
That is terrifying. It really puts the whole environment into perspective, though. Ignoring your HVAC system in a coastal town, it's like forcing a marathon runner to run a race while breathing through a salty cocktail straw.
That is a great analogy.
You have the ambient heat, you have the salt air actively corroding the aluminum parts, and you are just strangling the machine's ability to breathe.
Which is exactly why the optimal time for these interventions is the spring or the fall.
Right, the shoulder seasons.
Yeah, you want to clear the lines, clean the coils, check the refrigerant levels, and, test the electrical capacitors before the extreme summer heat forces the machine into a dead sprint.
Okay, so understanding how a dirty system drains your wallet through energy waste brings up an even bigger financial dilemma. Let's say I do the tune-up, right? But the technician finds a major problem.
Okay.
Every homeowner dreads that moment. The moment they have to decide whether to write a massive check for a repair or an even more massive check for a total system replacement.
Oh, yeah, the repair versus replace debate.
Exactly. How do we navigate the economics of that?
Well, there is a very pragmatic benchmark in the materials we looked at called the under 10 years rule.
Okay, how does that work?
Generally speaking, if your system is less than a decade old, you want to lean toward repairing it. You haven't fully realized the lifespan of the equipment yet. So making a moderate repair makes mathematical sense to protect your initial investment.
Right. But I'm guessing that math flips dramatically when you encounter certain red flags.
It does.
I would assume the biggest red flag is just the repair guy practically living at your house. Like, if he's out there 3 times a summer, you are clearly throwing good money after bad.
Frequency of breakdowns is definitely a major indicator, yes. But there is a silent chemical red flag that is even more definitive. And that's the type of refrigerant your system relies on.
Okay.
If you have an older system that runs on R22 refrigerant, which a lot of people colloquially know as older Freon, you are operating on borrowed time.
Wait, I've heard of the R22 phase out. What exactly is the mechanism behind that? Like, why does the type of liquid in the pipes force a total system replacement?
Because of its severe impact on the ozone layer, R22 has been universally phased out by environmental regulations. I mean, it is no longer manufactured or imported, period.
So you literally can't get it.
Well, the supply is drastically dwindling, while the demand from older units remains. So Economics 101 dictates what happens next.
The price goes through the roof.
Astronomical levels. If an older unit springs a leak, just buying the chemical to refill the system could cost you thousands of dollars.
Wow.
And you are putting that liquid gold into a machine that is already obsolete and degrading.
That makes total sense. You aren't just fixing a machine at that point. You're investing in dead technology.
Exactly.
But here's the part of the data that really caught my eye. The materials talk about the energy leap when you do finally replace a system. They mention upgrading from an older SEER 10 unit to a modern SEER 216 system.
Yes, the efficiency jump.
Right, and they claim it can slash your cooling costs by up to 40%. But before we look at that 40% number, what actually is a SEER rating? Is that basically miles per gallon for an air conditioner?
That is the perfect analogy. SEER stands for Seasonal Energy Efficiency Ratio.
Okay.
Just like a car that gets 30 miles to the gallon is cheaper to drive than a truck that gets 12, a higher SEER rating means the air conditioner requires significantly less electricity to produce the exact same amount of cold air.
A 40% reduction in your electric bill is staggering. I mean, it made me reevaluate what an aging system is actually doing. It isn't just failing to cool your house, it is actively penalizing you.
That's a good way to put it.
The motors are wearing out, the coils are corroded, the bearings are shot. The system is working overtime, pulling massive amounts of power from the grid just to achieve the same result it used to get with half the effort 10 years ago.
Which is why the return on investment for a new high SEER system can be surprisingly fast.
Right.
But, and there is a massive caveat here, it's a trap a lot of property owners fall into. Replacing your AC is not like buying a new refrigerator where you just plug it in and walk away.
Why not?
If you buy a premium high-efficiency box and attach it to terrible leaky ductwork in your attic, You will not see those savings.
Okay, but let's say my ductwork is fine. If my old system couldn't keep the house cool, my instinct is to just tell the contractor to give me the biggest, most powerful unit they sell.
Oh, wait.
Like if a 3-ton unit struggled, give me a 5-ton unit. That solves the problem, right? Give me the V8 engine.
Actually, buying a unit that is too large for your home square footage is one of the absolute worst mistakes you can make. It introduces a phenomenon called short cycling.
Short cycling? What is that?
Yeah. Remember earlier when we talked about how an air conditioner is also a dehumidifier?
Right, it pulls the gallons of water out of the air.
Right. Well, for an AC to pull water out of the air, it needs time. The warm air has to pass over the cold coils slowly and consistently for the condensation process to actually happen.
Okay.
If you install an oversized, wildly powerful unit in a moderately sized house, it is going to blast the rooms with freezing air. The thermostat will hit its target temperature in like 5 or 10 minutes, and then that massive unit will shut off.
Oh, I see. But because it only ran for 5 minutes, it didn't have time to wring the water out of the air.
Exactly. The temperature dropped, but the humidity remained entirely the same.
So you end up with a house that feels like a cold, damp cave.
Yes. The walls feel clammy, the air feels heavy, and here's the worst part. Because the system is constantly slamming on and shutting off every 10 minutes, the motors burn out twice as fast. A proper replacement requires a contractor to perform precise mathematical load calculations based on your home's square footage, window placement, and insulation. The machine must be perfectly sized to the space.
So the machine has to match the house.
Exactly.
But what happens when the architecture of the house itself is fighting against a perfectly sized machine?
Yeah.
I really want to get into the physics of comfort here because there is a very specific pain point in the data that I think literally everyone listening has experienced.
The hotspot issue.
Yes, you walk out of a freezing cold, crisp living room, you walk down the hall, you open the door to the master bedroom, and it feels like a sauna.
Yeah.
Why does that happen, and why can't my shiny new central AC fix it?
Uneven cooling is arguably the most frustrating issue for a homeowner. You have a brand new system, but you still have massive hot spots. And the reason a traditional central AC struggles with this goes back to the fundamental flaw of how we regulate building temperatures.
Which is what?
Most homes rely on a single, centralized thermostat, usually located in a dark interior hallway.
So the brain of the operation only knows what the temperature is in the hallway.
Yes. Now, imagine it is 3 o'clock in the afternoon. The sun is beating down relentlessly on the master bedroom on the west side of the house. The thermal load on that room is massive.
Right.
But the living room on the east side of the house is entirely in the shade.
Oh, I see the problem. To cool down that sun-baked bedroom, I have to walk to the hallway and crank the thermostat down to like 68 degrees.
Yep.
But by forcing the system to blast cold air until the bedroom finally cools off, I am simultaneously turning the shaded living room into an absolute icebox.
Precisely. You are treating the symptom, not the disease. And you are wasting a tremendous amount of energy overcooling empty rooms.
So how do we fix it?
Well, this is where advanced thermodynamics and modern technology come into play. The industry materials we're looking at highlight 2 major innovations that solve this: variable speed compressors and ductless mini-split systems.
Let's start with variable speed. How is that different from a standard compressor?
A standard compressor is single stage. It only knows 2 speeds, 0% or 100%.
Okay.
It is like driving a car where your only options are slamming the gas pedal to the floor or slamming on the brakes.
That sounds incredibly inefficient.
It is. A variable speed compressor, on the other hand, operates like a gas pedal. It can ramp up to 100% during the hottest part of the day, but as the house cools down, it can throttle back and cruise comfortably at 30 or 40% capacity.
Oh, wow. So it just matches its output to what the house actually needs in that moment?
Exactly. It matches its cooling effort to the exact physical demands, which provides incredibly precise humidity control because it runs longer at a lower speed, and it uses a fraction of the electricity.
That makes the miles per gallon analogy so clear.
Yeah.
But what about the ductless mini-splits? The materials point out that companies like Mitsubishi have really pioneered these units. I always pictured those as, the clunky window units you see in old motels.
Right, the window shakers.
Yeah. But the data suggests they are high-tech solutions for residential families and even small commercial businesses.
They're entirely different from a window unit.
Yeah.
A ductless mini-split system allows you to bypass the central ductwork entirely.
Okay.
You mount a sleek, quiet air handler directly on the wall of the problem room, like that sweltering master bedroom we talked about, and it connects via small refrigerant lines to its own dedicated compressor outside.
So you are bringing the mechanical cooling effort directly to the source of the heat exactly when it needs it.
Yes, it allows for true zoning. If you only sleep in the master bedroom at night, you only cool the master bedroom at night, you don't have to blast the kitchen and the living room at 2 in the morning just to stay comfortable in bed.
That makes so much sense.
And the result of this targeted surgical approach to cooling is a massive drop in energy waste. It lowers your utility bills and significantly reduces your overall carbon footprint, which is, a major victory for environmental sustainability too.
When you lay out the sheer high-tech nature of these modern solutions, I mean, we are talking about load calculations, variable speed thermodynamics, and precise humidity extraction. It is. And it becomes incredibly obvious that the hardware is only half the battle. You wouldn't hand the keys to a Formula One car to someone who only knows how to change the oil on a tractor.
Right.
It sounds like the actual installation and the local contractor you choose are just as vital as the SEER rating on the box.
So they're inseparable.
Yep.
A premium machine installed poorly will operate exactly like a cheap machine.
Really?
Oh, yeah. And when you are dealing with the extreme microclimates of coastal Florida, local expertise is paramount. You need a team who understands that an air conditioning unit installed on a barrier island, subjected to daily salt spray, is going to degrade entirely differently than a unit installed 15 miles inland in a new construction neighborhood.
So how do you actually evaluate a contractor? Because, I mean, anyone can buy a truck and print a logo on the side of it.
Very true.
What separates a highly qualified partner like Envairtech from a guy who's just going to swap a box and disappear?
Well, the materials emphasize a few non-negotiable criteria. First, you look for industry certifications. These are the objective proof of technical competence and ongoing education.
Okay, that makes sense.
Second, you demand transparent, upfront pricing. You never want to authorize work and then get hit with thousands of dollars in surprise fees after your unit is already dismantled in your driveway.
That is a total nightmare scenario.
It happens constantly, unfortunately. Furthermore, you want a provider that focuses on customized maintenance plans because every home's airflow dynamics are unique. And perhaps most importantly for this specific climate, you need guaranteed emergency support.
Right, because when you're dealing with extreme coastal heat, you don't just need a mechanic, you need a first responder.
Exactly.
You need a team who is going to answer the phone at 2 in the morning on a Sunday holiday weekend when your compressor dies.
Yes. And the good ones make it easy to reach them. Like Envairtech has their direct line right there, 941-355-3832, because they know emergencies don't happen on a 9-to-5 schedule.
Sure.
A premium HVAC provider doesn't just offer quick, one-size-fits-all fixes. They take the time to run the load calculations, they evaluate your ductwork, and they communicate honestly about the state of your equipment.
Yeah.
They are quite literally the gatekeepers to your indoor environment.
Oh.
The precision of their work dictates the quality of the air you breathe and the baseline comfort of your daily life.
So what does this all mean for you listening right now? Whether you are a homeowner trying to protect your family from a sweltering summer, a builder laying out the blueprints for a new construction project, or, a small business owner desperate to ensure your customers don't walk out of a hot storefront.
It applies to everyone.
It really does. The core lesson here is a massive shift in perspective. Proactive climate control is not a luxury expense. It is a vital protective investment. By scheduling those precision tune-ups, you are protecting the structural integrity of your property by preventing catastrophic water damage. You are guaranteeing the air quality in your home. And by optimizing the mechanical efficiency of the system, you are actively lowering your utility bills month after month.
You're paying a little bit now to stop a huge disaster later.
Exactly. You are essentially protecting your home and your wallet from a much bigger problem.
It is the ultimate shift from a reactive, panic-driven mindset to a preventative, scientific one. And as we wrap up this exploration of building science and airflow dynamics, I actually want to leave you with a final thought to ponder.
Oh, okay. Let's hear it.
We have spent this entire discussion dissecting how incredibly hard these modern cooling machines have to work. We are relying on high-tech variable speed compressors, intricate chemical refrigerants, and constant mechanical interventions just to hold the ambient environment at bay.
It's a constant battle.
Right. But it raises a fascinating question about the future. If our machinery has to work this desperately to fight nature, how might the very architecture of our homes need to evolve?
Wait, what do you mean by that?
Imagine a future where the house itself does the heavy lifting.
Okay.
Instead of building a static box and forcing an air conditioner to artificially cool it, what if our future homes are designed with passive cooling in mind?
Oh, interesting.
Yeah.
Yeah.
What if the orientation to the sun, the aerodynamics of the roof lines, and the thermal mass of the building materials naturally deflected the heat so the machine only had to step in on the very worst days?
Now, that is a profound concept to leave you with. A home that breathes in harmony with the environment instead of constantly going to war against it.
It's something to think about.
Definitely. But until that architectural revolution arrives, however, change your filters, schedule your seasonal tune-ups, and make sure your system has the tools it needs to win the battle against the heat. We will catch you on the next deep dive.